This one is the first step into higher level powers. We're going to try to start to develop something about what to do if I have a polynomial function. They're well behaved. So the derivative should be relatively easy to get them somehow because they're really well behaved functions. This is a freaking line. They are stupid well behaved, right? They're almost annoyingly well behaved. What would f prime of x be? Yeah, so it's really what this is question saying. What's the slope of that line? Well, you've known how to answer that question forever. You just waited till now to figure out what that notation meant. So that's -5. So let's real quick. Let's get used to sort of the way. If I had a linear function, how would I go about proving using calculus methods that the slope of that is a? Yeah, use a limit definition, right? So I'd have to do the limit. H goes to 0. F of x plus h minus f of x all over h. And this one's not too bad at all. You know? We're going to make a major jump after that we do this. Well, maybe I'll do an intermediate step. Let me see. What is f of x plus h? Yes, cool. And then minus f of x, so minus ax minus b. That's another big place people minus the whole thing, right? So you got to distribute that negative through. So you get ax plus ah. The ax and the b cancel. Left my poor little b out. So ax and ax cancel, b and negative b cancel. So I'm just left with ah on the top, and of course there I can see the problem canceling, like we talked about before. So of course this limit's just going to be a, which is what I knew. I knew the stupid slope of that is a. So if calculus told me something different, I'd say throw that shit out. Thankfully, we're not going to throw calculus out today. Oh, so close. Now, I think we've done, in fact, I think one of the first things we did was x squared. The limit definition for x squared. And we got 2x. You guys remember that? And that's where I pointed out the interesting connection. We saw today the connection between x cubed and x squared and x to the fourth and x cubed when we were tracing out the shape of the derivative. I like it, I like it. So let's do one more. Let's do a slightly evil one. Just a little tiny bit evil. And this is where I want to remind you guys or show you guys for the first time sometimes something called Pascal's triangle. Has anybody ever heard of Pascal's triangle? You guys? Okay. That's encouraging. I like that. So the limit as h goes to 0. X plus h plugged in there minus the function divided by h. If you've never heard of Pascal's triangle, it's related to something called, well, it's used in something called binomial theorem. Really what it is, here's the triangle. And just continue, so like 1 plus 1 is 2. There's always 1s on the outside. 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3, blah, 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 blah. So if I did like x plus 1 squared, this is x squared plus 2x plus 1. 1, 2, 1. 1, 2, 1. So x plus 1 cubed would be x cubed plus 3x squared plus 3x plus 1. So just to show you a more general example, a plus b to the 4th power, right, this is squared cubed 4th power, would be all a's plus 4, 1 less a, 1 more b plus 6, 1 less a, 1 more b plus 4, 1 less a, 1 more b, plus all b's. You guys see how that kind of goes? It's very beautiful. Shit, yeah. So here, I can use that level, or, you know, I can just multiply it out a couple times, doesn't really matter. So I get the limit, h goes to 0. What would it be? Three x squared h, 1 less x, 1 more h, plus 3, 1 less x, 1 more h, plus all h's. Isn't that kick-ass? Especially if you've never seen it before. There you go.